Sorry about that. Solving systems by graphing and substitution. Let's first talk about some vocabulary. What is a system? A system of equations is two or more equations with the same variables. When you're solving a solution is going to be an ordered pair that satisfies all of the equations. Then we have different types of systems. We have a consistent system where there's at least one solution. An inconsistent system has no solutions. An independent system has exactly one solution. And lastly, we have a dependent system, which has an infinite number of solutions. So when we're classifying systems, we're going to state whether the system is consistent and independent, consistent and dependent, or inconsistent. Again, consistent meant that it had at least one solution. Inconsistent meant that it had no solution. So again, if it's consistent and independent, it has exactly one. So the two lines would be intersecting and meeting at one spot only. That's the solution. Consistent and dependent will end up being the same exact line. So every point on that line is a solution. So it would have many solutions because the line goes on forever. And again, inconsistent system is parallel lines and they have no solution because they never cross. To solve a system by graphing, we're going to rewrite the equations in slope-intercept form or find both the x and y intercepts, and then graph both lines. Find the point of intersection, the solution, if it exists. So let's practice. Example 1, solve and classify the system by graphing. Check your solution. So again, there's two ways to graph without a calculator. You can solve for y to get it in slope-intercept form, which is y equals mx plus b format. So these are all written in standard form right now. Standard form was ax plus by equals c. And so to get it into slope-intercept form, you would have to move x to the other side. So equation 1, we have 4x plus 2y equals 4. First, to get it in slope-intercept form, I would have to subtract 4x on both sides to cancel it. That would leave me with 2y equals negative 4x plus 4. X's come in front. And then you would divide everything by 2 to get y completely alone. Show that you're dividing all parts. And you would end up with y equals negative 2x plus 2. The reason of doing that is to identify the slope. So m is your slope, which is negative 2, and b is your intercept, which is 2. So I would plot b, positive 2, on my y-axis, then use my slope, which says negative 2. That means go down 2 spaces and right 1 space to find another point. All you need is 2, and then draw them with a straight line. And you want to make the line much larger than those 2 points. So I'm going to extend it out a little more, trying to keep the same slope. All right, so that's line number 1. Make sure you put arrows at the end of your line to indicate it goes on forever. And a good idea would be to label the 2 points on the graph. So this is 0, 2, and this is 1, 0. So that's putting it in slope-intercept form. An alternative method is to find the x and the y intercept by covering up your x's to find your y, or cover up your y to find your x. You could use that strategy. It's not normally the best strategy if your x-intercept or your y-intercept is a fraction. Just keep that in mind. And you need these graphs to be pretty spot on if you're going to get the solution properly. Just remember that. So equation 2, I now need to write in slope-intercept form. So 2x minus 3y equals 10. I would subtract 2x on both sides. I'm not going to demonstrate that. I'm just going to show you the result. That would leave me with a negative 3y equals a negative 2x plus 10. Again, I subtracted 2x on both sides. And then I would divide everything by negative 3. Okay, which would give me a final equation of y is equal to positive 2/3 x minus 10/3. Now my 10/3 is a fraction, and as a decimal, it's about 3.3. So I don't want to use my y-intercept to graph this. So let's find my x-intercept. Again, we want to be as accurate as possible, otherwise our graph will not come out properly and we won't find the correct solution. Now, if you're using a graphing calculator, the graphing calculator is more than qualified to handle fractions. But by hand, it's a little bit more complicated. So to find the x-intercept, you would take the equation 2x minus 3y equals 10 and replace y with 0. So essentially you're covering it up, making this whole 3y turn into 0. And solve for x. So that would be 2x equals 10, divide both sides by 2, so x is equal to 5. Oops, 5. So my x-intercept is 5, 0. I'd rather use that point than my y-intercept. So let's plot 5, 0. It's right here. Now we already established that my y-intercept is 10/3, so we're not going to use that. But we can use the slope to find another point from our x-intercept. So the slope says go up 2, right 3. And if I did it again, I would be off the grid. So now I have 2 points for this second equation. I can draw a line that connects the two. So again, the solution to this system is the point of intersection. Where do the two lines cross? The two lines meet right here. That ordered pair is 2, negative 2. So let's check that solution to see if it satisfies both of the equations. And if it does, we found our solution. So we have 4 times 2 plus 2 times negative 2 and we're checking to see if that is equal to 4. So 4 times 2 is 8. 2 times -2 is a -4. And yes, that is 4. So it works for the first equation. Let's check the second equation. So 2 times 2 minus 3 times -2 should equal 10. So that's 4. -3 times -2 is a +6. And yes, that equals 10. So our solution is 2, -2. Now let me demonstrate this in the calculator. Alrighty. So again, in order to use the calculator, you have to put them in slope-intercept form first, and then go to y equals and type the equations in slope-intercept form. So equation 1 was -2x plus 2. The second equation was 2/3 x minus 10/3 graph. So the blue line is going to be equation 1, and the red line is equation 2. So if you want to use two different colors for each equation, that would be great. Now to find the solution, we would hit second trace and 5 for intersect. So move the blinking cursor down the blue line as close to the intersection point as possible. Hit enter. Then it jumps to the red line. So then you again get it as close to the intersection as possible and hit enter. And then it's going to say guess. That means hit enter one more time. And it tells you that the intersection has an x value of 2 and a y value of -2. So that's how you can check the calculator to see that you graphed it properly as well as found the solution properly. So please try example 2 on your own. Now we're going to learn about solving systems by substitution. The first step would be solve one equation for one of the variables. Second step, substitute the resulting expression into the other equation to replace the variable and solve the equation. Step 3, substitute to solve for the other variable. Sounds like a lot. It can be. So let's practice. So we're going to solve x plus 2y equals -2 and 3x plus 4y equals 6. I'm sorry, I forgot to classify the first system on example 1. That was consistent and independent. Consistent and independent meaning it had exactly one solution. Sorry. Now for example 3. It's a good habit to number your equations like I've done here. Equation 1, equation 2, in that order. Try and keep it consistent. I'm going to take equation 1 and solve for x. Because when I look at equation 1, x is the only variable in the entire system that is by itself or has a coefficient of 1. So that makes it easier to isolate. So when I isolate x, that means I would have to subtract 2y to both sides. So the equation would read x equals -2y minus 2. Again, all I did was subtract 2y to the other side to get x by itself. Step 2, substitute the expression. The expression they're referring to is -2y minus 2. And we're going to take that and insert it into equation 2. So in place of x. So equation 2 says 3x plus 4y equals 6. So now instead of x, we're going to replace it with negative 2y minus 2. That's why it's called the substitution method. You replace one variable with an expression. And now you only have one variable to work on. So to get y by itself, first thing I would do is distribute my 3, which would give me negative 6y minus 6 plus 4y equals 6. Then I would add 4y to negative 6y, which would give me a negative 2y minus 6 equals 6. Then I would add 6 to both sides, which would leave me with a negative 2y equals 12. And divide both sides by negative 2, you would get y equals negative 6. Now, the last thing you do is substitute the value from step 2. So the value they're referring to is y equals negative 6. You're going to put negative 6 into the revised equation 1. So remember, we took equation 1 and got x equals negative 2y minus 2. That's the revised equation. Could you use the original equation? Sure. It doesn't hurt. It's probably better that way. Anyways. So now I'm going to take y and replace it with 6 now that I know how much y is. Negative 6, sorry. And solve for x. So negative 2 times negative 6 is positive 12. And positive 12 minus 2 is 10. So my solution should be 10, negative 6. Make sure you put it in xy order, alpha order, x before y. So now you would want to check your solutions, of course, with the original equations to make sure it balances. So we say x is 10, so 10 plus 2 times negative 6 should be negative 2. So 10 minus 12 should equal negative 2. Yes, it does. So it works on equation 1. Check it with equation 2. So 3 times 10 plus 4 times negative 6 should equal 6. 3 times 10 is 30. 4 times negative 6 is negative 24. 30 minus 24 is 6. Yes, it works. So that is definitely my solution, 10, negative 6. And since it only has one solution, we would say this system is consistent and independent. Try this example on your own, and that concludes our lesson for today.